Okay, so let's say if we have 5 plus I and 5 minus I are complex conjugates. Yes.
Shouldn't it be like 7 plus 4
Oh,
and 7 minus 4
yep. Thank you. I think I was looking ahead to the next example. Okay. So what if you have just one term? Okay. So what if you have negative 6i? Okay. So in this case, negative 6i and positive 6i would be complex conjugates. And that's because if you make negative 6i, you can rewrite that as 0 minus 6i. Oh, sorry about that. I meant to put positive. Don't know why I put another negative there. And 6i, you can make that 0 plus 6i. Okay, so those two would be complex conjugates. So these two are complex conjugates. I guess you could say since. All right, any questions on that one? All right. Okay, so let's say, did I miss one? Nope, that was it. Okay. So if we multiply a number by its complex conjugate, just like with multiplying x plus 2 and x minus 2, the 2 will in the middle will cancel out. The only difference is the ones on the end, the signs will change. Okay, so I'll show you what I mean by that. Multiplying a complex number, which we'll call a plus bi, and its conjugate, we'll call that a minus bi, is a real number. A squared plus b squared. Okay. Now you don't have to remember that, but you'll kind of see the pattern if you do it enough times. All right, leave that up for a few seconds. All right, so let's say, for example, if you wanted to multiply 3 plus 5i by its complex conjugate. Okay, so the complex conjugate is 3 minus 5i. Okay, so if we multiply 3 plus 5i times 3 minus 5i, and just do the basic FOIL method, 3 times 3 is 9. Your outside is negative 15i. Your inside is positive 15i. And your last will be negative 25I squared. Okay. Now the 2 in the middle will cancel each other out. And remember, your I squared is negative 1. So you'll end up with 9 minus 25 times negative 1, which is 9 plus 25, which is 34. Okay. So you notice you really ended up with 3 squared plus 5 squared, which is 9 and 25. Like I said, you don't have to remember that formula because you can easily do the FOIL method, but it's just one of those things that people notice. All right, any questions on that one? All right. Okay, so let's say if we wanted to divide complex numbers, you multiply the numerator and denominator by the complex conjugate of the denominator. Slide that up a bit. All right. Oop, you still writing. Okay. All right, so let's say, for example, let's say if we wanted to divide, say for problem A, we have 3, make that a little bit bigger, divided by 6 plus I. And for problem B, we have 1 plus 2I over 3 minus 4I, and you want the answer in complex form. All right. So for A, we have 3 over 6, 6 plus I. Okay, so the complex conjugate of 6 plus I is 6 minus I. Okay, so that means our 3 over 6 plus I, we're going to multiply that by 6 minus I over 6. Why do I keep wanting to put 1 there? 6 minus I. Okay. Now the denominator, we just go ahead and FOIL these two. But the numerator, we can distribute that. Okay, so that ends up being 3 times 6 minus I over 6 plus I times 6 minus I. Okay, so if we distribute that one, 3 times 6 is 18. 3 times I, well, negative I is negative 3I. Okay. We can go ahead and FOIL here. 6 times 6 is 36. Your outside is negative 6I. Your inside is positive 6I. Negative 6I, positive 6I. And your last is negative I squared. Okay, so we know that I squared equals negative 1. I'll finish this up down here. So that gives us 18 minus 3I over 36. Those two middle terms cancel out. Minus negative 1. Okay, so we end up with 18 minus 3I over 37. Okay, which is right, but it's not in the right form. So we can separate those two to be 18 over 37 minus 3 over 37. And we just bring the I right in front. All right, so any questions on that one? Okay. Slide that up, and for B, go ahead and separate that. We have 1 plus 2I over 3 minus 4I. Okay, so the complex conjugate of your denominator of 3 minus 4I is 3 plus 4I. Okay, so we multiply the numerator and denominator by that conjugate. So that gives us, make sure that's up far enough, 1 plus 2I over 3 minus 4I times 3 plus 4I over 3 plus 4I. Uh-oh, straighten that up a little. Right. Then we just multiply across and do our FOIL method, but this time we have to do the FOIL method for both. Okay, so you have 1 plus 2I times 3 plus 4I over 3 minus 4I times 3 plus 4I. Okay, and I'm just going to pick that up right underneath it. So if we use our FOIL method for this one and our FOIL method, forgot a parenthesis, FOIL method for that one. In our numerator, we have 1 times 3, which is 3. Then you have your outer, 1 times 4I, which is 4I. Your inner, 2I times 3, gives you 6I. And your last, 2I times 4I, is 8I squared. Okay, your denominator, 3 times 3 is 9. Your outer is 3 times 4I, which is positive 12I. Your inner, 3 times negative 4I, is negative 12I. And your last, negative 4I, positive 4I, is negative 16I squared. Okay, so your denominator, those cancel out. Okay, but for both of them, we just want to remember that I squared equals negative 1. Oh, clean that up a little. Okay, which means that we end up with, if we go ahead and combine those two, 3 plus 10I plus 8 times negative 1. All over 9 minus 16 times negative 1. Move that up a little bit. So that gives us 3 plus 10i. 8 times -1 is -8 over 9 plus 16 is 25. Okay, so we end up with 3 minus 8, which is -5. Minus 10i over 25. And I knew I should have started further left. Okay. So if we wanted to, we could go ahead and just separate those and put it in the right form. And I'll make this a little higher. -5 over 25 minus 10 over 25i. And we can actually simplify both of them. So it would actually become 1 over -1 over 5. Well, I guess you could factor out a -1 for both of them. I guess you can make that. Oh, plus 10i. That's where I messed up. I knew that should have been plus. -1 over 5 plus 10 is 2 over 5i. Okay, and that would be your final answer. All right. So any questions on that one? Okay. Oops. Leave that up there for a few more seconds. All right. Okay, so let's say, for example, if you wanted to divide 4 plus square root of -16 over 2 plus square root of -4. And you want the answer in a plus bi form. Okay. Now this one would still work with the conjugates, but you can actually take a little bit of a shortcut with this particular type of problem. But it has to kind of have the pattern. Okay. So if we go ahead and make that instead of 16, we can make that square root of 16i. So I have 4 plus square root of 16i over 2 plus square root of 4i. Okay, we can go ahead and make that 4. Square root of 16 is 4, so we can make that 4i. Square root of 4 is 2, so we can just make this 2 plus 2i. Like I said, if you multiply both by 2 minus 2i, you still get the same answer. But if you factor the 2 out of here, you'd have 2 plus 2i over 2 plus 2i. Okay, so sometimes you can bypass all of the work involved with that. This just happens to be one of them. Can't do it all the time, but every once in a while. Okay, so these two will cancel out to just be 1. So your final answer is 2, which ends up being 2 plus 0i. All right, any questions on that one? All right, so let's do one more example. Let's say if we wanted to divide 7 divided by 2i, and we want it in a plus bi form. So remember that you can write 2i as 0 plus 2i. Okay, so whenever you have just one term or one imaginary term, you can make that into your complex form. So the complex conjugate of 0 plus 2i is 0 minus 2i. So the complex conjugate of 0 plus 2i is 0 minus 2i. Okay? And we can actually just write 0 minus 2i as negative 2i. So 2i and negative 2i are complex conjugates. Okay, so I said all of that just to say that. Okay, so 7 over 2i, we're going to multiply that by negative 2i over negative 2i. Oops, move that up a little bit. Okay, so you end up with 7 times negative 2 is negative 14i. 2i times negative 2i, you have negative 4 times I squared. Okay, so you have negative divided by negative, which is positive. So that's 14 over 4, and I squared, bless you, equals negative 1. So you have negative 4, well, those canceled out, times negative 1. Which ends up giving you negative 14 over 4, which simplifies to negative 7 over 2. Which, in your complex form, is negative 7 over 2. Oh, did I forget my... Nope, I did forget the I up here. So that would be, since it's negative 7 over 2i, it would be 0 minus 7 over 2i. As your final answer. All right, so any questions on that one? All right. Okay, so that's how you add, subtract, multiply, and divide. Oops, make sure anyone's still writing. Okay. Okay, so let's say, for example, I want to divide, and pick another one. Yeah, that's a pretty good one. Let's say negative 1 plus 9i divided by negative I, and I'll give you a few minutes to start on that.